Hey, welcome back to episode 4 on GenAI Foundation. Today we are going to cover the one intriguing question on the latest ChatGPT, Claude, how they work. Let us go inside and deep dive. I had a problem some years ago when I was testing a chatbot. I asked, "What is the temperature in San Francisco?" It answered perfectly. Then, after some time, I asked, "What about tomorrow?" It said, "I didn't understand the question." But now, the new ChatGPT Claude, they can easily answer. Earlier, if I give some long paragraph, after some sentences, it loses the context. It doesn't understand what it is speaking. But how the new LLMs are able to do that? This has happened because of 2017 paper by Google researchers, that is, attention is all you need. Let us understand our two unfinished stories. As in my just example, the memory problem, the RNNs, recurring neural networks, read one word at a time. To reach some word 100 has to cross all the existing words from 1 to 99, but by the time it reached 99, it forgot what is word number 1. So the same issue for the chatbot I have encountered few years ago. And the meaning problem just we have encountered in the episode 3. So that is the bank problem. The bank, the financial institution, and the bank, the river bank. So it doesn't understand the meaning, but the issue in both the cases, it is the root cause is same. It is not able to get the context from the nearby words or within the sentence. Both the problem, whether it is a memory problem or the meaning problem, the root cause is same. Let us see how we resolve using this attention mechanism. As I told, in 2017, the Google researchers have published a paper called "Attention is All You Need." The fix is very simple. Instead of reading the words one after another, you look at the whole sentence. Read the entire sentences at a stroke. Every time, weigh what actually matters. This is a simple concept, but it's a game changer, and it is the foundation for these new LLMs based on the transformer architecture. Here, the transformer reads a sentence and 5 stages start to finish. The first, you already know, I have covered so many times on the tokens. It is breaking raw text into tiny pieces, and computers doesn't understand the sentences like humans we do. It converts into numerical representation, numbers, embeddings. And third is position. Here, this is a new addition because earlier the computers were reading sentence word after word, so it knows the position already. But once in this transform based architecture, it reads the entire words at a stroke, so we need to feed the position also. We should tell you remember this order. And finally, the attention. This is the hero of this episode. From the neighboring words in the sentence, it gets the richer context, the meaning will be added more. And finally, the output. This is the beauty of the transformers. Finally, it can predict the next word. This is how it is generating the text. If you can recollect the episode 2, this is the same prediction training loop: predict, measure, adjust, and repeat. It predicts the output during the training, but output is wrong. For example, I love to eat pizza, but it gives something textbook, then it is wrong. So the prediction goes wrong. It measures the error. It should be pizza, but it has given some novel name. Then all the weights are adjusted, and again it repeats. The same machine learning concept we are using here also. Here the architecture in one picture, if we break down or combine into 3 components, these are the 3 components repeats over and over. Here the embedding layer, the token becomes vector and the position is fed in for the dog, for example. And the transformer layer, this is where attention happens. Here you see the right side, GP3's depth, 96 layers, the transformer layers. Maybe now in the latest models there are thousands of layers. That is the reason they need so many GPUs, because it doesn't happen one after another. This transformer layers, it happens simultaneously. For that, massive GPUs stack is required. And finally, the output layer, you see the embedding layer converting the text or human readable words into vectors, numbers, numerical presentation. Finally, unembedding, that is reverse from vectors or numbers to the text. Then we are arriving at the final prediction word: I love to eat pizza. Let us see how it happens stage by stage. Stage 1, tokens. A model cannot work on a raw sentence. It first split into fundamental units called tokens. I love to eat. This is the sentence given in ChatGPT or in Claude. Here, what it does, it converts it into tokens. I love to eat, 4 tokens, and each token will get a unique ID. Like we have in the modern English, we have 50,000 to 100,000 IDs are assigned to each word. Every token gets a unique ID, but that is just a label. Model still doesn't understand. For example, I may be having number 1, eat may be having some 50,300. That is a ID only, but doesn't signify anything. That is the significance comes from the next stage, that is embeddings. Words become numbers. Now you see the dog is having some numerical representation, features addition. We have seen in detail in the primer series. Watch the vector episode in the primers. And wolf and car. If you observe closely, the dog and wolf are having the same or similar closure numbers, 0.23 and 0.25, because both are animals. But in case of car, it is completely different. Here we are able to compare all the similar words will get in the similar vector space, closely placed. The dog and wolf land close together in vector space. Here we have given the 5 dimensions only, but in the real world case, there may be 768 to 4096 dimensions per word. That is a huge number. Why not just one number? In our earlier example, we have seen 5 features, but I told there may be 4096 features, dimensions. Why can't we use simple number like dog 1, wolf 2, car 3? We have so many numbers, right? Let us see the problem. With a single dimension, unrelated words collide. Example, stock, let us say we have given 5.2 is the number. That is a financial word. And capital we have given 5.3, again a financial number. Because both are financial, they are close, 5.2 and 5.2. But you see the opposite of stock, that is rare. You can have the same word but different meanings. Stock here in this sense, not financial, but some quantity, huge quantity. So opposite is rare and it gets minus 5.2, opposite. And capital, here the capital opposite is debt. That is minus 5.3. But you see here, both words are completely different, uncommon, and one is opposite of capital. But how in the negative 5.2 and 5.3 they are close to each other? So we cannot define like this with a single number. Rare and dead end up with near identical scores, but they have nothing to do with each other. If we have these numbers, we can derive something even more, like hundreds of dimensions give a model room to represent relationship like this. For example, I have king, man and woman, but I don't have queen in the training set at all, but I can derive it easily using this mathematical representation. For example, king is a royal thing and I have removed the masculine thing and I have added the feminine thing. Bingo! I'll arrive at the queen, and it is proven also. So with these hundreds of dimensions, we can neatly do the mathematical representations. Now the stage 3, position. This is the beauty. In earlier RNNs, we are reading one after another these words, but in case of transformers, particularly attention mechanism, we are reading all words simultaneously. Transformer sees every word at once, which means on its own it has no idea what order they came in. But let us see the problem here. The dog chased the cat chased the dog. In the first sentence, the dog is the chaser. In the second sentence, cat is the chaser. If any first grader spots the difference instantly, but transformers without help cannot. It needs order added back-in deliberately. Let us see how it happens. The word embedding, in our previous example, you have seen the 5 dimensions, and the position 2 is embedded. Here it is the position 2. The one vector for position 2 is this one, and both we are doing simple addition. We got the final vector. Don't worry, it doesn't change the meaning at all because there are hundreds of dimensions. It's a simple slight nudge is not going to make a huge difference. Now the stage 4, the hero of the today's episode, the mole problem. We'll see the 3 sentences, same word, 3 completely different meanings. American shrew mole. This is some kind of animal, and 1 mole of carbon dioxide, and take a biopsy of the mole. All 3 are different but is having the common word mole. Now without attention, you see every mole in every sentence got the same vector, one fixed vector, same in all 3 sentences. Whether it's an animal, a unit of measure, or skin spot, doesn't matter. This is the exact same thing we have covered in the episode 3, the bank problem. In the lab also we have covered the same thing about the bank problem. Whether it is a river bank or it's a financial institution, money bank, both get the same vector. Now, how the attention is going to solve this? You see here, the American shrew mole got different vector, carbon dioxide mole got the different vector, and biopsy mole got the different vector. Every word is re-weighted using its actual neighbors. This is the attention. Here we are giving the attention from the neighboring words. 3 sentences now produce 3 different vectors. beauty of this attention. Here it is happening the inner workings using query, key and value. Every token plays three roles at once inside each transformer layer. Don't worry, we will see what is query, key and value. Query, I think you must have do the Google search. Some query you might have given what I'm looking for, something you want to know. Now the key can be already indexed pages. What does each word offer? Now the value, the content to actually pull in. You got the final result. Let us see with an example and understand what is query, key and value. The sentence is the cat sat on the mat because it was comfortable. When the model processes it, the query asks what noun am I actually referring to in the entire sentence. That query gets compared against every other word's key. So here the key possesses that I am not a noun, it is some article, and cat, here I am the noun, and sat, something, again mat, again noun. So in the words that answers best win the most attention. Here in this case noun, we are having two strong contenders, cat and mat. Let us see how it updates the meaning of it. One by one, it asks the query, key and value, and these are the final value from each neighboring token. Now the beauty happens here in the bottom one, output of it. Output of it, earlier it was simple vector. Now after completing the attention mechanism, it has the more value from cat and mat. So now it represents more of cat features. So this way model is able to understand that it means it is cat. Not only that, it is a single layer you have seen, and it does so many layers. Early layers understands the basic patterns like grammar. Just now we have seen whether it is a noun, verb or something like that. But when we go deep into the middle layer, sentence structure it can figure out. Means cat is the subject and mat is the location phrase. And we are going into further layers, it understands the abstract meaning, that is the physical situation. Cat is resting and it is comfortable. But it is like a no human Google engineer or some Claude engineer fixes this. Early layer should be grammar, middle layer should be this one, and deep layer should have the abstract meaning. Not like that. It is during the training these meanings will emerge. And finally the output layer, that is an embedding and Softmax layer. Here the example is I love to eat. That's what we have started. And now it can be pizza, it can be food, it can be sushi, it can be idli or something. How it happens? As we told in the initial layers, it's an embedding. We get the tokens and convert to the numbers, and we applied the attention layer for each word in the sentence, like how it gets the contextual meaning from the cat and mat. The similar way, when we go deep into the layers, each and every token will get that, and finally we arrive at one vector. Now the vector will be compared with the existing vocabulary that we have covered 50,000 to 1 lakh or 100,000. So then it will arrive at the final words similarity score. The similarity score here, it is having 75.2 highest. We apply the Softmax. Softmax beauty is it converts everything into 100%. Then it can predict that I love to eat pizza. Picking the next word, how it happens? The model does not always take the top score. It samples. A roulette wheel is weighed by probability. Like this. Now we have it two ways. Can I pick pizza? But should I pick always pizza? Because it has given the highest probability? No. When we do the creative writing, more randomness is better. That is the creativeness, right? More random is the creative. Otherwise, if all humans think in the same way, then there is no creativity at all. So it gives a roulette wheel. Out of top 5, sometimes it selects pizza, sometimes it selects food, sometimes it selects sushi. You can try for yourself. But in case of code generation, always Python code should generate the same output. It should not give some different things. So we can use less randomness. Always you pick the top one, highest probability token it picks. So that is how it picks the next word. Let us put it all together once again. Now somebody has given in the chart the capital of France. The first word it predicts from the unembedding layer output is. Then again the capital of France is we are giving as an input. Now this time it predicts Paris with highest confidence 95%. Then again we have given the capital of France is Paris. Once again it predicts dot. Then again it gives end of sentence, then it stops. So here you see automatically how it is calculating every time. Now the problem with the huge sentences is every time it has to reprocess the entire input. You see here for generating Paris, it has to give the capital of France is. For generating the final output, it is to give the capital of France is Paris. Now, if your sentences are longer and longer and longer, the context size will become very huge and it slows down. That is the reason I think now you may be able to understand why it is slowing down for the next sentences generation. Now we understand that everything so far. Let us see something on training and inference. Here we are seeing the cat is sitting comfortably on. Somebody has given. Now it has given car, lap or mat. But the correct answer is the mat, but it has given the lowest score. You can recall the episode 2. We have given a handwritten example. It has given wrong and we are told you have done wrong. It is calculated and back propagation. It adjusts every weight, embeddings, all attention layers and embedding. Everything happens. Slight nudge to the weights and biases that we have covered in the episode 2 and repeats across billions of examples. And weeks of training happens on thousands of GPUs, then weights freeze. Then inference. Now you simply give the cat sat on the now bingo. It predicts with highest probability 76% it picks. Samples mat and returns it. No weights change. Same 5 stages every single time. Now the initial stories are resolved. The memory problem is resolved because it is not seeing the 100th word and recalling the what is the first word. No, it is seeing all words simultaneously. And the bank problem also was resolved. The mole problem you have seen how the attention has updated the mole. Similar way bank also is updated. Same fixed 2 problem, 1 mechanism that is called attention. What we know now, tokens, it is a splitting the raw text into the fundamental building blocks, then embeddings because computers don't understand it needs numbers. Then we have fed the position because we know the dog chased the cat and cat chased the dog. Both are different. We are giving the position also. And finally the query, key and value, that is the attention because every other word is having some key and the it in our example asks the query and everything has told that I am noun, I am article. Like deep into the layers if we go, the more value will be emerged and the it contextual representation completely varies. Before the attention and after the attention. Finally, the output. It measures from the entire vocabulary and picks the right word. If it is more creative writing, then the probability distribution can get out of the sample. But if it is a code generation, we don't want randomness. It picks the highest probability predicted word. Before going further, let me demonstrate you. This is the simulated environment. Let us see what we have covered so far. Every modern LLM like GPT, Gemini or Claude can finish the sentence instantly, but how it is able to do it? Let us see one by one now. As I told, the text become tokens. It is into the capital of France is, that is we are going to generate the capital, the IDs I told just before in the slides. Each token gets some ID, but that is not useful for us. Now it converts into the vectors. You see here the capital. Here I am giving some 5 representations only in the vector space and some are already close together. Let us see about the position also. You see the capital we are adding. This is the first position, this is the second position, third, fourth, like that we are adding the positions also. But the combined word, don't worry about the representation of the combined word, it gets the same meaning. And here the beauty here, the cat sat on the mat because it was comfortable. Let us understand one by one. Now let us generate the query. It generates the query. The question this token is asking the other words. Now you see it is asking the other words. You are able to see now. Now it compare with the keys. So one by one it is comparing. Finally the cat emerged the highest and mat emerged the second highest. Now apply the Softmax. You see here it is not converting into 100 or 10 something, but we need a standard model. That is why applying Softmax, it is simply converting everything into the 100%. That's it, not any magic. You see now it is representing cat more. Now we blend the values. You see now it is having more features of cat and it in the vector representation, it is closely positioned next to the cat. It now incorporates the weighted values led by cat at 75%. Now we'll see even the it goes further refinements, run in the basic patterns, emerges, middle layers, structure, roles, relationships, and deeper layers, rich high level features emerges. But here we are not doing anything, or some software engineer does not do anything. In the training it emerges. Now let us see the problem. The capital of France is, let us say we give London, and how model scores. Yeah, you see here it is Paris. After applying Softmax, you see Paris emerged highest probability. Then again run one by one. The capital of France has emerged. Then again capital of France is Paris. Again cycle 3, capital of France is Paris dot. You see how every time it is again giving entire tokens. This is why tokens gets consumed very quickly. Now the problem is resolved. You know now how a machine writes a sentence. It is tokens, embeddings, position, attention and output. No hand waving. If you like, please subscribe and like the video and comment. Thank you very much. Peace.